Okay, so we are ComputeAway. We are a team of scholars, and with the complication of our modern computer programs, we don't always have the computing power we need at home. Google Cloud, Microsoft Azure, and other large-scale computing providers can be hard to access and are not tailored towards small compute applications like ours. We sometimes have to pay enormous costs, both monetary and environmental, to run our simple tasks. And on the other end of things, many people have computers in their houses that lie fallow, a waste of resources that would be perfect for our compute needs. Our solution utilizes the blockchain to connect the users in need of compute to others who have underutilized compute that they want to profit from. The blockchain would consist of blocks of compute that at a certain time for that computer suppliers are offering in exchange for C coins or compute coins. The price of compute will be determined by the supplier. In addition to being traded for compute, these C coins can be traded for real world money. This creates a cycle. A user has a C coin, they give it to a compute supplier in exchange for an hour of the compute on the supplier's computer. This supplier then sells a coin to another user in exchange for Ethereum or any other monetary medium they agree upon. This second user uses this coin to buy compute, and the cycle starts again. Now, you might be wondering, how is this system safe for the supplier's computers? Can't anyone upload malicious code? No, they cannot. Our system uses a combination of methods to combat malicious use. We plan on running a custom Linux-based virtual machine with untamperable console log and no access to the outside computer on the supplier's computer. And for compute user security, we plan on having smart contracts with every transaction that guarantee that the compute is delivered. This smart contract will also limit the user's accessibility to the supplier's computer, and will specify the compute price, time, and duration. Right now, there do exist decentralized computing platforms that utilize blockchain, but we believe that our solution is both different and better. We have significantly better security than our competitors with our custom Linux virtual machine, and we are the first system to have smart contracts essential to our system, which offers a plethora of customizable features and security. We do not set our price like other competitors. We believe that the market for compute is dynamic, and the price should be set by the supply and demand, not by an outside system. Lastly, most of these systems are made for decentralized computing applications, while our system is meant to be used by traditional small-scale compute, being used by deep learning or Fusion 360. Thanks for your time, and welcome to the chain.
Well, I'll ask a question. So just practically speaking, what would this mean for like a TKS student? Like if they wanted to work on an ML project, how would they interface with what you've developed here?
Sorry, one second. Yeah, so actually I was trying to, Stephen, I actually messaged you about this earlier about how I was searching for large scale compute. I need around whatever, a lot of compute for machine learning project I'm doing pretty soon. Stay tuned for that. So they would be able to interface with this by kind of buying some of the compute tokens, some of these C coins, by trading some Ethereum to somebody who already has these C coins. And then they'll look on the blockchain, they'll like say like in our GUI or whatever, they'll say, so I need this compute on Sunday from 1 p.m. to 3 p.m. I am willing to pay at most 3 C coins an hour. And then it'll look on the blockchain for somebody else who's saying, okay, I want to sell compute from 1 to 3 p.m. on Sunday, and the least I'm willing to spend is 2 coins. So then it'll maybe like go in the middle and sell for 2.5. And then like, okay, so now I'll have that machine. I can do like with a SSH or a virtual environment and VS Code, whatever I want to do. And I'll be able to run my code there to train my machine learning models, and then I'll be able to just get that back.
Cool. Okay. Awesome.